Today we are going to learn about advanced Python conditional logic with chained comparisons. We will explore how to simplify Python conditional statements using chained comparisons, enhancing code readability and efficiency. Welcome to our session on advanced Python conditional logic with chained comparisons. In this video, we'll delve into the fascinating world of Python's chained comparisons. This technique allows us to write more intuitive and human-readable code, which is crucial for complex data processing tasks. We'll cover everything from understanding the basic syntax to exploring real-world applications, ultimately equipping you with the skills needed to enhance your Python programming efficiency. Let's get started. Chained comparisons in Python allow you to compare multiple conditions succinctly. Unlike traditional logic statements where each comparison is separate, Python interprets chained comparisons in a single, efficient operation. For example, instead of writing a less than b and b less than c, you can simply write a less than b less than c. This not only makes the code easier to read but also more efficient. Python evaluates chained comparisons by checking each condition in sequence, ensuring that all conditions are true before returning true. This feature is unique to Python and is one of the language's most powerful tools for writing clean, readable code. Let's delve into the syntax of chained comparisons. The syntax is straightforward. You write the variable followed by operators and the values or other variables you want to compare. For instance, a less than b less than c checks if a is less than b and b is less than c. This can be extended to any number of comparisons, like x less than y less than equals z greater than w. You can use chain comparisons with both numbers and strings to evaluate sequences in a logical flow. Consider this practical example. To check if a number n is within a specific range, you can write lower underscore bound less than equals n less than equals upper underscore bound. This syntax is not only concise but ensures the logic is easy to follow. Chained comparisons offer several benefits that enhance Python programming. Firstly, they improve code readability. By writing conditions in a single line, you make the logic transparent and easy to follow, which is essential for collaborating with others or revisiting your code later. Secondly, chaining reduces logical errors. By minimizing the use of explicit and or operators, there's less room for mistakes. Thirdly, it enhances performance as Python internally optimizes the sequence evaluation. This streamlining is particularly beneficial in complex conditions where nested comparisons can become cumbersome. Overall, chained comparisons simplify the logic, making your code cleaner and more efficient. Chained comparisons are invaluable in data validation tasks. In real-world applications, they help ensure that data meets specific criteria before it is processed. For instance, when validating user input, you can ensure that a value falls within an acceptable range by using chained comparisons. Suppose you're developing a form where users must enter their age. To validate that the age is between 18 and 65, you can write 18 less than equals age less than equals 65. This simple yet powerful line of code ensures data integrity and improves validation efficiency. Such usage is common in applications ranging from web development to data science, where maintaining data accuracy is crucial. Chaining comparisons significantly enhances code readability by presenting a clear and concise code structure. When conditions are expressed in a single line, it reduces complexity and eliminates redundant logic. This makes it easier for developers to understand the code quickly, which is particularly beneficial in collaborative environments. Additionally, it simplifies maintenance and debugging. When errors occur, it's easier to trace the logic in a straightforward, easily readable format, reducing the time spent identifying and fixing issues. By adopting chained comparisons, you contribute to writing code that is not only efficient but also accessible to others, fostering a collaborative coding culture.
When working with large datasets, performance is a key consideration. Chain comparisons offer efficiency in processing such data by minimizing the number of evaluations needed. This can have a positive impact on the execution speed of your program. Unlike traditional methods that require multiple checks and logical operators, chain comparisons streamline the process, reducing the computational load. However, it's important to balance readability and performance. While chain comparisons improve readability, ensure that they do not compromise the efficiency of data processing tasks. By leveraging this technique, you can optimize your code for both readability and performance, making it suitable for handling extensive datasets. While chain comparisons are powerful, they can lead to errors if not used correctly. Common errors include misplacing operators or misunderstanding the logic flow. Debugging these issues requires a careful examination of the conditions and ensuring that each part of the comparison is correct. If you encounter unexpected results, double-check the syntax and logic. Avoid common pitfalls, such as assuming that chained comparisons work like regular and conditions without understanding their evaluation process. Employ strategies like printing intermediate results to identify where the logic may be failing. By being vigilant and methodical, you can effectively resolve errors and harness the full potential of chain comparisons. To maximize the benefits of chain comparisons, it's vital to adhere to certain best practices and coding standards. Firstly, ensure that your code is consistent with the overall style and standards of your project. This includes using meaningful variable names and maintaining a consistent format in your comparisons. Aim to balance complexity and simplicity by not overcomplicating conditions unnecessarily. Simplicity leads to more sustainable and scalable code. Regularly review and refactor your code to incorporate best practices, keeping it optimized for both performance and readability. By doing so, you ensure that your code remains robust, easily understandable, and adaptable to future requirements.
In conclusion, understanding and implementing chain comparisons in Python is a valuable skill for any developer. This technique not only enhances code readability but also optimizes performance, making it a crucial tool for complex data processing tasks. We encourage you to practice using chain comparisons in various scenarios, from simple validations to intricate data processing challenges. By applying what you've learned today, you'll be able to write more intuitive and efficient Python code, greatly benefiting your programming projects. Thank you for joining us, and we look forward to seeing how you will implement these concepts in your work.